So welcome to the pre-recording of lecture 18, the second half of session 9 in the 8-week summer course, Introduction to Computer Science. Um, so this is in the beginning of the fourth week, and in the middle of the fourth week we will have our review and then our midterm exam. In a way, this lecture marks an important milestone. It's the first half of the course in which we, in some sense, have already covered many essentials of computer science. So the internet can definitely not be absent. Python itself plays a very important role in the internet. Python is a good language to define web servers. We will not do this in this course, set up our own web server, but in this lecture we will see how we can use Python to browse the internet. We can actually request information without the help of a web browser. So this is quite cool. Our efforts of the previous lectures, how to work with files, will actually translate into recovering data from the internet. And perhaps something that I should show right away, so I will open up a new terminal window. We can ask Python for the weather forecast, or actually it's not a built-in feature of Python, but we can write a Python script which produces the weather forecasts. So I'm typing this up on Saturday evening, July 1st. So Tuesday, the 4th of July is an important day, so it's a holiday. And we can see that it will be a sunny day in Chicago, but the next day we may already have thunderstorms. And also tomorrow we may occur thunderstorms. So this can be done via a very simple script, and in some sense the main goal of this lecture is to explain the script. So that is, I'm going to introduce this in the second part. So, but just this is kind of the end of the first half of the course. I hope you understand my enthusiasm. We have already covered quite a lot, and we can write very nice scripts. Okay, what do we actually need to know about the internet now? First, some history. So very telegram style. Uh, Started in the 70s, and I'm using the historical development for some abbreviations. So TCP stands for Transmission Control Protocol. IP stands for Internet Protocol. Um, so in the 70s, there was the development of electronic email. So I started using computers in the 80s, and at the end of the 80s, I started my research career, and then email was something that was commonly used between researchers around the time. Now everybody has an email address, but at that time, it was that was the main benefit to the general public. Protocols, agreements are necessary between people who communicate, also between computers that communicate. The internet, if you like, was encountered another important milestone. That was with the development of HTML. HTML, the ML, the HT stands for hypertext, and ML stands for markup language. This was also to communicate, but now information. So you can, of course, uh, distribute information via email, but with HTML you can uh, distribute, you can post information in a structured manner. The web browsers came one came very shortly after, although you could say 70s, 90s, 80s, 90s. The National Center for Supercomputer Applications is at the University of Illinois. So the development of Mosaic, the very first web browser, we can at the University of Illinois we can have some pride into this development. Search engines originated also at the end of the 90s, so this made really the internet extremely useful as we already know it in modern times. The Web 2.0, that's the area where we currently live, is that at currently you are not only a passive consumer of information, but you can also participate in the forms of wikis, for example. There is Wikipedia, the free and online encyclopedia. And that means that as a user, without actually having to have very extensive computer science literacy with basic computer literacy, you can actually participate to the internet. Okay, every computer has every computer that is connected to the internet is a node. So it has an IP address. You can look it up via NS lookup. So if your computer is most likely, of course, you would otherwise not view this. Your computer is connected to the internet, and you can check on your internet settings what is the IP address. It's important to recognize in the symbolic name the difference between universities, government, military, commercial, and organization. And we distinguish between the internet, the wide area network, but then there are also local area networks, LANs as they are called. We will see also how computers in Python can communicate with each other. So with Python, there is a very nice interface for that as well. More terminology. We have URL. URL is a uniform resource locator. Uniform again indicates the um, uniformity, the protocols. It's also a little bit similar as we have seen with files. You have the file name and then you have the absolute file name where something is on a disk. In some sense, the uniform resource locator tells where every file that is hosted on a web server can be found. You have the symbolic name here of a web server, here of the web server of our department, then linking to my personal home pages, and then the main course website for this class. In general, we have a protocol, we have a host name, we have a path, and then there is the data name, the name of the file. So I'm again using the file. So we have web browsers, but we also have file browsers. File browser is very similar to a web browser. When actually it comes to um, graphical user interfaces, we will actually see the terminology or the technology in this class to write your own web browser. Today we will see how to connect to a website from within a Python script. Um, Web servers serve web pages. Clients are other computers that request web pages. But the client server, um, way of thinking, way of organizing distributed computing is very general. So you can have a database server, you can have one computer that serves information via a database to several computers that connect to it. You can also, if you have again your local area network, suppose that you have several computers and you want to build your own um, supercomputer, so you want that several computers are collaborating with each other, then you can set up a client server network where the server is responsible for distributing work and resources towards the other computers. So client server computing is applied with web servers, but it is a very general way of organizing computing. So you could see this in a purely administrative fashion. If you have one central database in a large organization, or you could also see this in a computing facility where you have a computing resource that is um, managed in a client server way. So it's a way of organizing computations. In a way, in computer science, a better word would often be computing science. Okay, HTTP, not to confuse with HTML. So HTTP is the Hypertext Transfer Protocol. It is a protocol that defines the way data is exchanged between client and server. So there are many steps how a client computer, any computer, gets data from a server. But here are the main steps. So there is a TCP IP connection, and the IP stands for Internet Protocol. The TCP, look it up, was one of the very first slides. So there are the connections that are established between browser and server. From a server perspective, you can set it up in a way that certain clients from certain domains do not have access. And the opposite can also happen, also that your browser is actually giving you warnings not to visit certain sites. There are probably certain sites that you shouldn't be visiting, but there are sites that are kind of deemed not safe, and I will get to this. So then there are the steps 2 and the 3, and 2 and 3 can actually happen in a loop. So here there is one single request, and that gets sent from the client to the server, from the browser to the web server. The server actually sees whether it can locate the file, and then it replies. The server is typically multi-threaded. It may have multiple requests at the same time. The browser may also, you may have multiple browser windows open, and you may also request multiples, and that could be in a loop. At the very end of every request, the connection is closed, just like we close a file. So we will have open and closing. Markup languages. So there is HTML, so the language in which you can display information in a formatted manner. We have the XML and we have the MATML. So there are many markup languages. So markup languages are languages that allow to structure information, that actually add information. So we have information as stored on file, stored in a database, but the markup language takes this information and adds extra layers onto this. I will give examples to this. So there is Markov, so there is, I'm sorry, mathematical markup language. So MathML can actually display complex mathematical expressions. So this is a mathematical computer science course. So you can, for a structure of an expression, you can actually indicate how that expression should be interpreted. This is rather abstract now, but this information can be used for rendering the information. There is one website that you probably are encouraged to visit. So there is the World Wide Web Consortium, which promotes several standards for the web. So also how you should organize your web pages, especially um, if you are the web manager in an organization, you should adhere to certain standards on how the web you organize your web, your information. Here is an example of an XML structure. So this is not the XML, but this is how you could organize an article. So if you have an article, say a newspaper article, it has a title, date, an author. The author has a first name, a last name. There is a summary, and then there is the contents. The contents itself can still be distributed into several sections. Can have an introduction, a main parts, and a conclusion or something like this. But this is how you could structure an article. And this is defined in the XML. So seems like I'm just could say a lot more. But let's go to Python. And this is the main thing that I want to get across essentially. So this is the last lecture before the review, and in some sense I do not want to overload with too much material, but I hope you find this cool. And we will see that it doesn't take too much code to produce this information. And of course, you can always launch your browser and look at things, but this is just the execution of script from a terminal window. Um, how do you get data from the web? Well, there is a URL lib module. Uh, Python comes with batteries included. So there is an URL open. It's similar to the open that we have seen with files. So what you get back from the URL open, if it is successful, is an object through which you can ask for information from the um, you can read line by line, for example, as we will see. Now, the we ended the previous lecture with the reading files byte by bytes. Uh, if you read from if you read from URL pages, it always enters in binary format, so you must decode. CGI programming. So there is the Python as a web client. You can also Python is also one of the main applications of Python is as setting up a web server. Actually, Python itself contains all the tools that you would need to set up your own web server. This is not really within the scope of this first introductory course. But this is kind of another way of saying why Python is still so popular and why is still Python still so widely used. CGI programming. So CGI programming is very similar to graphical user interfaces. In the second part of this course, we will go into graphical user interfaces, in particular because graphical user interfaces are one of the applications where you will see that object-oriented programming is really necessary. It's also another way of thinking about programs. You think about programs that not executed um, from line to line, but more event driven. In some sense, we already know this when we are using the Jupyter notebook. So we can organize and we should organize our Jupyter notebooks in a way that they run from top to bottom, but actually you can execute any code cell at any given order at any given time. So the Jupyter notebook in some sense already, as you like, an interface to your Python interpreter. Web interfaces are also event driven. So if you understand how to design good graphical user interfaces, you also uh, understand how to um, write good web servers. Now, where does Python come in? Well, Python adds the dynamic aspect of the web pages. So web pages at the very beginning, they were static, just displaying static information. But Python can be used to print markup language. It can print extended. So this is this XML into HTML pages. So you have used already more than likely, whenever you use actually a search engine, when you type in a query, you actually uh, type in the input form of a web page, and then the web server will take your input and write a page with uh, hopefully what will be what you were asking for. So in Python, so there is the common gateway interface that you can use. And that is what via the CGI module in Python, this is how you can write scripts that print dynamic web pages. It is not strictly within the scope of this course, but you must know where Python fits within the internet world. All right, what's the difference now between HTTP and HTTPS? And this is actually something that you should know without looking it up. Because whenever you used the internet for a commercial transaction, it should have been done through an HTTPS website. So that's a website that is somehow certified as authentic, where there is a central organization that matches the computer, the actual computer, with the domain name. That often, if you go to a website, it can actually list its domain name. But if there is no HTTPS in there, then the protocol is not really safe or secure. So the S stands for safe and secure. Um, Make your own web page. So you are students at UIC. There are also other um, other tools and resources that you can use for free. But the university has people. So every student, every faculty can actually have a website. Uh, the website also comes with a server, so there is a terminals interface. Make your first web page. So this is an important activity. Go to that website and follow the steps. I will. So this lecture is a little bit centered around this forecast script. So you can make some modifications to it. Perhaps you are not so much interested in Illinois, and or perhaps you want your own where the place where you live in Illinois, you want to know where it is, or if you're going to travel, you can look up other locations in the United States. And there certainly should be similar websites around for foreign destinations. The last exercise asks you to download Python scripts. You could, of course, download this with a browser, but you can immediately download it if you are in uh, a script or if you are in a Jupyter Notebook environment. This could be useful. You could immediately, if you know, of course, you know the course website, you know, for example, a name of a script, you can immediately put the script, see the code that you would need. Often much more useful than a general search engine. All right, let me now go to the notebook that I have prepared. Um, So there are two sections in this Jupyter notebook, and the main goal is actually to explain how the Jupyter, how that forecast script was built. There are three pieces, three steps actually. The first piece is to get the URL right. So I was fortunate that I was using this from 2017. So the 2017 script that I had somewhere was still valid. So I mentioned in the earlier lecture the project Gutenberg. You can actually also download the Lady Macbeth of Shakespeare directly via what we're going to do now. So you can, in some sense, you could read novels and plays in with a Jupyter notebook. It's kind of completely awkward way of looking or strange way to look at text, but in in a way, if you ever have to camouflage that you're working within you're working within a Jupyter notebook doing very serious things, whereas you may be browsing the internet, looking at texts online. All right, there is the URL. So here is the URL in full. I want to indicate here that there are several pieces. This could be useful if you want another state. So here I split it up, the host name, then the part of the file, so the structure. With a browser, you can most likely go to data forecasts and state, see what actually is there. Um, I think I only selected from Illinois the region where Chicago was. So there are many files there from Illinois. I mentioned, so it could be that if you look at the output here, that you're kind of disappointed that in this output, not all locations in Illinois are present, but it is nevertheless already an extensive file. So when the opening is successful, so you need the URL open. I imported it here, and it is using the with syntax also here. The main difference is that for my or for convenience, I name it page, short for web page. So we see the web page just as we see um, file that we have opened as a binary, as a in binary mode. So I'm here using the decode. I left off the UTF-8, which I prominently used in the previous lecture, but it works, so the UTF-8 is the default. So I just want to see if I have the URL right, and then you see everything what is in there. There is actually, so at first you don't really see that much, but then it gets interesting. So there is this legend here. So it forecasts the temperatures, the early morning low and the daytime high. And then also in the second line, you have the probability of the interpretation. So eventually you could also print out these lines. I'm not showing these those. The lines that are very useful are the lines following here. So you would like to know for which dates the forecasts are. That's kind of critical. And then you have for this file all the locations that are available. And the ones that are interesting to us are the downtown area or Chicago O'Hare. If you live in the suburbs, Joliet or Kankakee, then these are the locations you may want to look at. Um, but there's too much in here, so I'm not, or we are not interested in this. So the purpose of the script is actually to only have the legend. So I want to see essentially for which date is the forecast, and also only the lines for Chicago. So here it is. So in some sense, it's not entirely pedagogical, but that I'm already showing the output right away. But I should have done this in two. So you have the FCST. So the FCST was followed by two lines. And I'm having the current line, I'm splitting on the space. So what I have is a line of strings. So actually more pedagogically justified would be that I print out the L and then still have it run. And then you will see lists with strings in them. So there are no locations that name FCST would be a very strange name for a location, for a village or a city. So there is the city Chicago, so I select everything that is in Chicago. If I'm not interested in O'Hare, or if I'm interested in O'Hare, I would only locate O'Hare. So you see that it will be pretty hot in Chicago. It will be 90 degrees on the 4th of July. Um, All right, that's the essence of it. So you see the decode is already there. I decode as soon as I have applied the read line on the page. In some sense, again, not too pedagogically correct. I should have seen that if you have not the decode, then you actually have a byte sequence of bytes that you can still see. I mean, but it's not really something that you should use for processing. So thunderstorms are likely already for Wednesday, but that could already happen Tuesday evening. There are also showers, and also for tomorrow, or at least for me tomorrow on the July 2nd, thunderstorms are likely. All right, so you can also make this better and kind of the I'm guessing actually that it is thunderstorms. I actually haven't looked it up, but you could provide a legend for Sunny doesn't need a legend, but the PTSCLDI probably does. So you can provide a legend. All right, the main purpose of the exercises is that you actually play with these scripts. So then the last or the second part is actually a reinforcing, but now combining the reading from a web page onto copying on a file. So this is for the last exercise. So the last exercise asks you to write a Python script that downloads this. And actually, if you have to do this really, do we have to really have to do this? So there is the wget. So the wget is a very useful utility that allows you to get an HTML file. If you know the complete URL, that includes also the file name, then you can immediately download with one statement at the terminal prompt. So in a way, this script could be useful in the sense that it allows for prompting and giving some feedback. So later in the course we will see exception handling. So you could first try to open a web page, and instead that your program would simply crash, you could give a retry or try to indicate in a nice manner that something went wrong with opening the file, opening the website. Okay, so the wget is very important, and I feel actually now that I have to demonstrate it. So you can do wget and then the name of the website. So now I have the course website, and you see that I'm actually already likely to make typos. So you see MCS 260. And there is this forecast script. See what will happen. This is in the Windows PowerShell, and my internet may at this point not be collaborating, but here it is. And it actually shows me the content, and everything was okay. Um, so this is if you have to do, so in some sense, this is computer literacy as well. How do you download something from the internet if you know the if you know the complete file name without a browser? So in some sense, um, that file also over here, I can actually, if I knew this entire file, so opening this file here, I can actually also do this with wget. All right, let me illustrate how you can now see the code, and you can display the code line by line, or there's also essentially the read. So these are scripts nicely formatted with new lines proper in there. So you could also start reading byte by byte. Especially, and we may get to this, but perhaps you have heard about web crawlers. Uh, these are programs that are going to crawl the uh, internet from site to site. So you could actually open one site, say you go to the main website of UIC, and then you look for all the anchors. You look for the websites the site of UIC refers to, and you go to those sites. So that is something that is an application for what we are doing now, but also not strictly within the scope of this course. Um, I want to copy the script. Let me first see that I have everything right. So the URL, I just typed it in without error because I have practiced this. The course URL, and then the name of the script. So if you write your download script, you could eventually have that as a constant sitting in there. Then you don't have to do that much typing. All right. Here we go now. We are going to write to file. So in a way, there is not much to extend. So in a way, this is an application of what we covered in the previous lecture. I have on input now a web page. So it was opened before and closed. I'm opening it here again. The file that I will download, I will call it download.py. If you like to download this in a separate folder, say in your downloads folder, then you have to provide the complete path name. So on your file, on your disk, you do have a folder downloads. So if you want to download there, then you have to provide the complete path name. We are going to open for writing, and it will be a plain text file. And the file is just called file. So we go from a web page to file. Every line is decoded. Therefore, it is already a string. So I can write it directly. And it is a string that already has the new line in it. So I don't even need to write the new line in there anymore because it is very nice, already formatted. You see when I print, so this is another way instead of printing all the lines. So I open the entire file download.py for reading as a text file, all the lines, closing the file and then printing the the lines one after the other, suppressing the new line symbol. And this gives me the definition of the Python script. Okay, so I'm 40 minutes in. So in some sense, this is the last lecture on the of this course, the last lecture of the first half. So please don't give up; it's not yet done. And this was on the internet. So you all have been using the internet and throughout, but I hope that this lecture was still useful. How to view now the internet more from a programmer's perspective. That we can use Python programs to retrieve information from the internet. Okay, I will stop here. For once, this was a somewhat shorter lecture. Um, but I have given the essence. So perhaps something still about HTML. So there is the hello world.html. You see, if I open the HTML here, you see our hello world. So one of the exercises is to make a first web page. Here is hello world. And I should illustrate what this page looks like. I called it Hello World HTML. So here it is. So the HTML file starts with HTML and ends with slash HTML. So these are the opening and the closing. Every HTML page has an header. So the header, this is what you will see when you open the page. That will be on the title. So here it actually says it, title, hello world. Then we have the body. We have the header. So the header, this is what is shown here. And then we have the text we can emphasize. There is some simple, so the writing HTML is not that much harder than Markdown, what we have been using already in our web pages. And then I was mentioning anchors. So there are anchor items. So we have HTTP references. So here you see the main website of UIC. And in some sense, this goes, let me now, if I clicked on this, so let me open an editor window. So I want to edit something because it's a little bit dated. So I will open an editor window and see this as a text file. So I will open from path. So this was the hello world.html. I cannot edit this. So in some sense, I need to edit this then as a text file. So the editor is knows HTML. You see trust HTML, distrust HTML. Yeah, that doesn't matter. All right. I have to save this file or copy this file and save it as a text file before editing. So here I do have a text file and I had the information sitting there as well. So I have my untitled. So I don't want this here. And actually I wanted everything on the same line. Um, so you see, there is also the new paragraph. So I want to start a new paragraph after this is the new, this is our first web page. So there is the link. So there is the text that appears at the link. So now probably it is good that I can see. So if I click on here, you don't see this, but perhaps I can show it. So if this is the complete, let me move something here. So if I move this, and if I'm scrolling over this, then you can see that at the bottom left corner there is the www.uic.edu that appears. So in a way, click on this and nothing happens, but you can see it has a little bit the same features. I said nothing happened, but something did happen. My internet is probably slow. Um, so it refused the connection. So not much lost. It could be that my internet is not good enough to act as a browser, but it would surprise us a little bit that I could use JupyterLab as a web browser as well. Or perhaps it shouldn't. All right, I'm babbling too much. The main point that I actually wanted to say is that here is our basic HTML. So just as we didn't really have a markdown full tutorial, I hope that you will know enough. So I will save the text now as hello world markup language. Save this as a text file. So of course, if I want to properly use this as HTML file, I have to rename this file removing the extension. Secure copy and secure file transfer is also very useful. I'm assuming that by now you would know this, but if you have problems with this, let me know. So you have your space on people.uic.edu. The files that you have, you can eventually ed um, edit them there on site, but it's often more convenient to edit your HTML files locally and then transfer them. All right, I'm not so sure now if this is getting interesting because this is too practical, and if you get in trouble, what I'm saying now will probably not help you that much. So I will stop the recording.